In this year of 2017, Wiley has published a new book on methodology and philosophy of science in psychological research. The book is titled Psychological Science Under Scrutiny, and is a good bet for the purpose of improving psychological science. Now, there is a chapter in this book that caught my attention, chapter 8, titled The Need for Bayesian Hypothesis Testing in Psychological Research. And it caught my attention not because of its Bayesian end, but because it starts the chapter by criticizing the logical foundation of p-values. And therefore, I took the opportunity to give my thoughts about this important topic, dealing with the philosophy of science. I have broken down my discussion into 3 videos, if only to keep the discussion a bit more localized and improve or foster more clarity in my discourse. In their contribution, the need for Bayesian hypothesis testing in psychological science, Wagenmakers and collaborators have the main purpose of discussing the logical basis of frequentist statistics. The prime argument being that a logical or a valid logical conclusion cannot be achieved via the use of p-values. Now, this is not a new discussion, and actually can be traced back at least till the 70s. What is new in Wagenmakers and collaborators' argument is that they generalize those criticisms, those historical criticisms, to the p-value itself, and not just to the procedure of null hypothesis significance testing. I have written a small article on this chapter, which is published now, but I will use these videos just to go a bit deeper in more detail on what I express in that article. The whole idea behind the illogical nature of p-values is that it appears to follow a logical syllogism based on Modus Tollens, but it fails to do so because of the inferential nature of research. And for Wagenmakers et al. And other critics, this prevents from achieving a valid logical conclusion when using both p-values and null hypothesis significance testing. Now, null hypothesis significance testing is controversial. Even myself, I have commented on that elsewhere as well. So I will understand or be more acceptable about the illogical nature of the procedure, because it's a mix-up of Fisher's approach, Neyman-Pearson's approach, and Bayes' approach. And therefore, even because of this mix-up, it should not even be considered or even dealt with, right? The originality of Wagenmakers and collaborators is that they extend logical validity of conclusions to the p-value itself. That means to Fisher's approach to test of significance, and even to Neyman-Pearson's approach to test of acceptance. So my discussion will be just relative to the p-value and to Fisher's approach, and also to Neyman-Pearson's approach. Now, Modus Tollens is a logical syllogism for invalidating a theory via finding evidence against expectations that we expect from that theory. So let's say, for example, if we have the theory that all swans are white, then we expect, obviously, as a consequence, that any swans and all swans we could observe will be white. And that will be the antecedents implying this consequent. Now, if we were going to find even one single case of a black swan, that will deny the consequent, and by doing so, will also deny the theory. Therefore, we have to conclude that because of having observed a black swan, not all swans are white. And this is basically the structure of Modus Tollens. We could certainly create a Modus Tollens for frequentist data testing. In this case, if the null hypothesis is true, then we have certain expectations. In this case, that the result will be non-significant, or that the p-value will be below the significance level. And if we were going to find evidence against this consequent, basically we were going to find a significant result, then we are in a good, valid position to invalidate the null hypothesis. Now, I'm going to show you how the Modus Tollens works specifically. So we have this antecedent leading to a consequent in the first premise, and a second premise that denies the consequent. And in so doing, in denying the consequent, then it denies the antecedent in the conclusion. Okay, I will show you here very quickly. Now, those criticizing the logical value, the logical basis of p-values and frequentist statistics is not, they don't deny this relationship of Modus Tollens. What they go is onto saying that because inferential research is based on probability, the Modus Tollens doesn't work. And there are like three typical, even historical examples regarding this, okay, to show how the Modus Tollens breaks down when using probability statements. One of the syllogisms that typically come up is the following. Well, if an individual is a man, he will have very low probabilities of being Pope. Now, if we come to know that Francis is Pope, then we ought to conclude that Francis is probably not a man, okay? Which seems like absurd, obviously, because we know that Francis ought to be a man. So, but is this an argument in favor of the critic? So, in this video, I'm going just to focus on the relationship between the second premise and the consequent. Basically, whether the second premise denies the consequent or not. And I will show you here. We can see, if we translate that low probability into, let's say 1%, let's say if an individual is a man, he will have a 1% probability of being Pope. We know that probability is much lower, but let's use it just for didactical purposes. So when we move on to the second premise that says Francis is a Pope, does it not deny the consequent? To me, it doesn't seem so. To me, Francis is Pope, despite having such a low probability. Therefore, we cannot conclude, or we cannot deny the antecedent, because we cannot deny the consequence. This example is simply affirming the consequence, which is kind of a fallacy. Other examples they use follow the same structure. So for example, if Tracy is a woman, an American woman, she will have very low probability of being also a congresswoman. Let's put it a 1% chance of being a congresswoman. And we come to know that Tracy is a member of Congress. Can we conclude therefore that she has low probability of being an American? Again, it's the same. Being a member of Congress does not deny the low probability of so being. So again, we are into affirming the consequent and being formally unable to conclude as the critics tends to conclude. And the same happens with the third example. If John doesn't have extrasensorial perception, then he won't win tonight at the casino. He will have a low probability, of winning at the casino. And then we come to know that John wins. Therefore, can we conclude that John probably has extrasensorial perception? Again, no. Let's translate that into numbers. If John has a low probability of winning, given the antecedent that he does not have extrasensorial perception, the fact of winning is only an affirmation of that probability. That is, that he won despite his low probability of so doing. And it does not deny the antecedent as the critics contemplate. And we can see that very quickly here as well. So the main argument I have against the critics, or those posing that the p-values are based on an invalid syllogism, is that the second premise that they are using does not invalidate, does not actually negate the probabilistic consequent they are also posing. Therefore, if there is not denial of that consequence, I conclusion denying the antecedent is invalid. So where does the confusion come from? I think that the confusion comes from taking the observed p-value as a probability of the results that justify the syllogism, while actually frequentist inferential statistics is based not on the observed p-value but on the selected level of significance. So I'll show you very quickly here. So what we see is that the null hypothesis gets divided into two portions. One where the null hypothesis is going to be accepted or retained, and the second one, beyond the level of significance, whether we are going to decide that an observed p-value falling on that area is going to be taken as evidence against the null hypothesis, therefore reject the null hypothesis. Therefore, what we have is not a probability statement here. What we have is a syllogism based on, if the null hypothesis is true, the results that we obtain will be non-significant. And if we obtain a significant result, then we can take that and validly conclude that the null hypothesis is not true. Now, remember here that what is important is the level of significance, not the p-value. So it's up to the researcher to decide which level of significance satisfies them. It could be a conventional 5%, it could be a smaller 2%, even 1%. And recently I was talking about a new proposal that came recently about making this level of significance as small as 5 per mil. But what we have here is, it doesn't matter how it is. What matters is at which point the researcher decided that values observed p-values will become evidence to be taken against the null hypothesis. Therefore, following this non-denial of the antecedent, of the consequent, and therefore being illogical to or invalid to also deny the consequence because of that issue, we can argue against the critics, and from this it shows that, at least to me, frequentist testing using Fisher's approach and Neyman-Pearson's approach is based on sound modus tollens.